30 degree to 60 degree set square of 60 mm longest side is so kept such that the longest side in HP making an angle of 30 degree with VP. The set square itself inclined at 45 degrees to HP. Draw the projections of the set square. Now we need to start with the problem, whether to start with the problem from the horizontal plane or from the vertical plane. So first we need to identify the surface inclination. Here he says the term the set square itself. So that means the entire surface of the set square itself is inclined at 45 degrees to HP. So obviously we have to start the problem from HP because the surface inclination given with respect to HP. So initially we will take the surface inclination with respect to HP as 0 degrees. In other words, it means that the surface inclination is, the surface is parallel to HP. Once the surface is parallel to HP, we are finding the true length in HP. How to identify that? When you look from the front view, we can see the surface which is A dash, B dash, C dash is on horizontal plane. That means all the sides are parallel to HP. So we are getting the true shape here in the HP. He says that the longest side is so kept such that the longest side is in HP. So since the longest side has to be in HP, obviously that edge should be perpendicular to VP. So that means when you look from the front view, you must get a point in the front view. So that is AC is the edge which is the longest side which is perpendicular to VP. Therefore, we are getting a point in vertical plane. So then once we keep this, when you look from the front view, A and B is near to the observer. So A dash, B dash is visible and C is away from the observer. Therefore, C dash will be in bracket. So here we have 60 degree to this and we have 30 degrees to this. So that is what we have shown here in the 2D analysis. So first we have drawn the 60 mm line and which is perpendicular to VP because that is the edge which has to rest on HP. Then draw a 30 degree from A and also draw a 60 degree line from C. Both will going to intersect at this point B. So this becomes the 30 degree, 60 degree set square. Either you can take 60 degree here or we can take 60 degree here. So there is no hard and fast rule that we have to take 30 here and 60 there. We can do it 60 here and 30 here. So that you will going to get the 30 degree, 60 degree set square. Then in the, so the longest side is in HP. Since the longest side is in HP, so we can see here the longest side AC is in HP and the set square itself is inclined at 45 degrees to HP. So when you look from the front view, we can see the surface inclination where we have the 45 degrees to HP. So when you look from the top view, the projected point which is the small b, so this will going to be small a to b, b to c and c to a. So this will going to be the top view when it is in, when the surface is inclined at an angle of 45 degrees. That is what we have shown here. So this sketch and this sketch will going to be the same. But in the second position we can see the set square is inclined at 45 degrees to HP, but still it is perpendicular to VP. So that is the reason why we are getting a line in the front view. So here we can see that A dash, C dash is on HP. So then when you make a 45 degree set square inclination, when you make a 45 degree inclination, so draw a line, you measure the distance and cut it here and then write the corresponding top view, which will going to be the set square. But this will not be in the true shape because here A dash, B dash and B dash, C dash both are inclined to HP. So AB and BC are apparent length and A dash, C dash is parallel to HP. So we are getting the true length in HP. So this line AC, this is what I'm showing here, which is AC, which is in true length. Now when you go to the third position and making an angle of 30 degree with VP, so here he has given the true inclination. So here, so since the length is also a true length, because we can see here the line is parallel, the longest side is parallel to HP, so we're getting the true length in HP. So see, this is the true length and it is also inclined, which is 30 degrees. He has also given the true inclination. So from the projections of lines, always on true inclination, we will going to get the true length. Therefore, rotate the second position top view by an angle of 30 degree with respect to VP, and then write the corresponding top front view, which is going to be like this. Similarly, that here, so rotate the second position top view by rotating at an angle of 30 degrees and then project the respective points so that you will going to get the front view here. So this front view in the third position and this front view in the third position, both are one and the same. So here, how do I know that my problem is right? So we can see here the longest side EC is on HP. The side which is resting on HP is inclined to VP at 30 degrees, and then the surface is inclined at 45 degrees, and a 60 mm, that is 30 degrees 60 degrees square, having a longest side of 60 mm. So this is how, since we have satisfied all the given conditions, and hence this is how we can do the analysis of both 3D and 2D analysis. Now we are going to solve the problem in the sketchbook. So to do that, first we will going to draw the XY line and mark XY and VP and HP. The line which you have drawn for XY line should be a very thin line. So then, since he says the longest side is kept in HP, so you make that longest side perpendicular to VP. So first we are going to draw a line and measure the length of 60 mm in the sketchbook, and then first you mark these 2 points, and you mark this as A and this as C. Then using the protractor with respect to the line AC, you measure an angle of 30 degree from the center A, and also from center C with respect to EC, you measure an angle 60 degree. Then draw a line from C to that 60 degree and extend, and from A you draw a line to extend the 30 degree mark which has been done. Both will going to intersect at this point, and you mark this point as B. Then join A to B, B to C, and C to A with the dark lines. Then draw the projection from A to C and A to the XY line, and also from B to the XY line, and then mark this. When you look from the front view, this will A and B is visible, so therefore A dash and B dash is visible, and C dash is away from the observer, so it becomes invisible. Then join between A dash and B dash with a dark line. Then since it's the longest side is kept in HP, so A dash C dash, take any convenient distance and mark the point A dash C dash is on XY line. Then by using the protractor with respect to the XY line, you measure an angle of 45 degree and draw an inclined line. Then you measure the length from A dash to B dash by using the compass, and then with the second position A dash C dash point, cut an arc on that 45 degree line and mark this point as B dash, and then join A dash B dash with a dark line. Then we need to write the corresponding top view. So from A dash and C dash, draw a vertical projector to the top view, and then draw a horizontal projector from A and also from C. Both will going to intersect on this projected line at this point which is A, and at this point which is going to be C. Similarly, you draw a vertical projector from B dash to the top view and draw a horizontal projector from the first position top view. Both will going to intersect at this point, and you mark this point as B. Then join A to B, B to C, and C to A with the dark lines. Then as we know that since A dash C dash is parallel to HP, so AC is in true length in the second position top view, and also the given inclination is also in true inclination. So rewrite the second position top view so that you will going to be rotated at an angle of 30 degrees. So first consider any point and draw a horizontal line here first. Then by using the protractor, and you mark the point as C here, by using the protractor with C as center, measure an angle of 30 degree with respect to the horizontal line, and then draw an inclined line here to the bottom side. Then you measure the length from C to A by using the compass from the second position top view, and with third position C point, cut an arc on this 30 degree line which has been drawn, and you mark this point as small a. Then you measure the distance from A to this point, and correspondingly from A you transfer it on to this line. So you're going to get this point. So from this point, you take by using the protractor, you measure an angle of 90 degree with respect to AC, and then draw a perpendicular line to second position. From the second position top view, you measure the distance from this point to B, and from this point you transfer the distance here. Then you mark this point as B, then join A to B, B to C, and C to A with a dark line. Then once you do that, write the corresponding front view. So draw a vertical projector from A to the XY line and draw a horizontal projector from A dash C dash, and similarly draw a vertical projector from C to the XY line because A dash and C dash is on XY line. So you're going to get the points as A dash and this C dash. And draw a horizontal projector from B dash and draw a vertical projector from B. Both will going to intersect at this point, and you mark this point as B dash. Then join A dash to B dash, B dash to C dash, and C dash to A dash with a dark line. So this is how you will be able to draw the sketch in the sketchbook. So show the dimensions of 45 degree, and this is 30 degree, and this is 60 degree, and this is 60 mm. So this is how you will be able to write the final solution. And then to check whether our solution is right or wrong, so you can see the longest side is still on HP in the third position. The longest side which is resting on HP is inclined at 30 degrees to VP, and the set square itself is inclined at 45 degrees. And we can have the longest side of 60 mm having a set square of 30 degrees to 60 degrees square. Since we have satisfied all the given conditions, and hence our problem is right.